OpenStack, but also Open Compute. So next, joining me on stage is Aaron Sullivan from Rackspace, and Aaron is a distinguished engineer for Rackspace's infrastructure strategy. So please help me welcome Aaron Sullivan.
Good morning. I want to talk to you a little bit today about Rackspace's experience with systems engineering and OpenStack DevOps. I want to talk more about our experience as a consumer of the platform than as an engineer of the platform, to give you a little bit of a sense of the lived experience of integrating both of these systems together at Rackspace. Before I do that, I want to say congratulations to everybody here and to people that are in the Open Compute Foundation. This is our first summit in Europe, and I think a sign of the progression and the maturity that the movement has gained. This is a picture that you see on screen of Rackspace celebrating a big milestone in the number of employees that they had hired a few years ago. If Rackspace people, Rackers, were here today, I think you would see similar streamers and lots of noise being tossed around the auditorium. First, a little bit about Rackspace and our first days with OCP, and I'll share a little personal story as well. Rackspace has over 200,000 customers using a wide variety of our services, and I like to think of that as 200,000 unique IT shops that we manage. And if you are part of an IT shop function, or perhaps you've been employed in a few different companies' IT organizations, you know how different each one can be. Their cultures, their strategies, their management structures, the way they do engineering, all very different. And we're a service company. We try and cater to the needs of each client on a very individual basis. And with those 200,000 customers, 200,000 IT shops, we have over 100,000 servers deployed and many more networking devices and switches and so forth. Many of them, outside of our public cloud infrastructure, have their own customized, dedicated environments. And you can imagine the kind of complexity that that engenders across our data centers and with our own teams as we try and launch new applications and find ways to service those end users more effectively. And the customers we have run a wide gamut. In our early days, we tended to serve a lot of web startups. In the late 90s, that was a big part of the business. But as time goes on, and we move upstream into bigger and bigger enterprises, we see customers with offices that are more like something operated out of a garage or a home office or studio. And we see those that are much more mature and much more corporate. And again, that also brings complexity into our picture. To give you a small sense of our portfolio, we have three major functions to our cloud service. We have a public cloud service, the Rackspace Cloud. We have a managed hosting service, which we sometimes also call our dedicated hosting platform. That's our oldest and longest running service. And we have a number of private cloud services that we deploy and support customers with as well. And within each one of those environments, there are a variety of hypervisors, a whole wide variety of applications, different storage systems, different server platforms, customers in large quantities, server counts and devices in large quantities, and a whole variety of applications in an environment where we say we want to have a close touch with our customer. It's complex. Now, I have a confession to make. When Rackspace first got involved with Open Compute, I was not a fan. I spoke up vocally with our lead engineer that was working on the project at the time and with some of our leaders, and I said, we run a very complicated platform. There's a lot of value we look to deliver to our customers in a bunch of different ways. And we've been down the road of designing our own systems before and integrating them, and it takes a lot of effort, and I don't know if our customers really value that. Sure, we'll save some money, but there's a lot of cost inside an organization to taking on these systems that haven't been designed and engineered and then sold through traditional channels. And I don't know if it's worth it, so I resisted. I confess that was a mistake. Actually, as I've learned being involved with Open Compute since we got really heavily started with it, we've actually benefited in ways that I was not thinking of at the time. A lot of people like to think of Open Compute as just a way to save some energy, save money on their equipment and so forth. And I think those are important and critical functions, but they are not the most important part of what Open Compute does for you. Open Compute actually makes you faster and more effective with your service offerings once you get up to speed and you're doing it right. And it gives you a level of control over your business and your infrastructure and your offerings and the speed at which you innovate that you don't have when you don't use Open Compute. Let me give you a sense of that just briefly. Earlier this year, we were up on stage at an Open Compute Summit in California, and at the time, we talked about some of our progress delivering platforms and what was in production and what was not. I'm going to tell you a story about our progress this year, about how Open Compute and working within it has helped us to accelerate the rate at which we deliver platforms. I'm going to talk about the investments that we've made within our own organization and what it's like working with our product managers, with our developers, our IT people to get these platforms out into our data center and supporting applications for our customers. So, by the numbers, since the beginning of this year, we have had 12 design starts on Open Compute solutions. Sometimes these are servers, sometimes these are whole racks, storage platforms, and so forth. This is us interacting with our business to determine a new kind of infrastructure to deploy for an existing application or a new one. From those 12 starts, we've gone to 8 fairly rigorous lab proof of concept efforts. Those 8 have gone to 8 field trials, beta tests, and so forth. Of those 8, we have launched 7 platforms within our cloud, within our new Onmetal service, and also within Rackspace's business intelligence platform. We hope to launch one more before the end of the year for an internal application. And we have had an increase in our throughput. Those numbers represent an increase of our throughput of about 100% year over year, with no increases in our engineering staff year over year. Looked at another way, in the second half of 2012, we were pretty engaged with Open Compute at that point in time, and I was still resisting. We had one design that we'd started. And you can see that we made some incremental investments in our staff to support Open Compute and the applications that we run. But we had made not much more significant investment by the second half of 2013, and you can see the amount of throughput that we've increased. We are launching more platforms than we have at any point in the past. We are designing more platforms than we have at any point in the past, bringing in more new technology. Those are all items that can make your business operate with much more complexity. But in this case, the amount of control that we get over the platform and the amount of direct interaction that we have with our partners really gives us a chance to cut down on what would otherwise be a lot of noise in that process. We can zero in on exactly what we value and what we need, and we can tune and optimize those components. And we've discovered that when we tear the stack apart and we really start to get focused on what matters to us, we actually move much more quickly than when we're trying to integrate components, software and hardware that weren't otherwise originally designed for us. You put a lot of effort into trying to kind of grind off those rough edges or make those square pegs fit in round holes. And with Open Compute, we can get the right size peg right off the bat. This is a picture of most of the engineering team that we have. This group doesn't just support Open Compute, they support all of our other server offerings and some of our operating systems as well. Just a few engineers, a few project people, a few people working in our sourcing and partner division, and a couple of development functions, and some managers. It's not a really big team, but this is the team that has shipped all of this equipment. So now I've told you about our team. I want to talk about our customers now. Our first Open Compute offer was to be integrated with OpenStack Nova to support Rackspace's cloud infrastructure as a service, sometimes just known as Rackspace Cloud Servers. This is one of my customers, Thomas Dusing. Thomas is the product manager over a very large number of servers and a good-sized chunk of Rackspace's revenue. And it's a pretty mature offer at Rackspace today. He's offering a solution and operating in a world that's more like that bigger, more mature customer that I talked about earlier, the kind that we service outside of Rackspace as well. Could be risk averse. There's a lot riding on trying new things, and a lot riding on trying to integrate software that was built for another platform on new or different hardware. It took us about a year working initially with Thomas and his team to get to the point where they were ready to take this application on. But we discovered that most of the challenges that we ran into dealt more with coming to grips with the original operational model and the change in software. And there was a lot more fear than there was substance to getting the application integrated. We eventually got that platform launched. We actually added a great deal of value to our cloud service platform at the point of that launch. Rackspace's Performance Cloud was sort of born with the notion that we could take a lot of these performance-enhancing items that we were putting into the servers and we could do something new and better and different. And we poured a lot of that into our open compute designs as we pushed that product into production. We have, so far this year, launched 2 open compute platforms for Thomas's offer, and we hope to launch 2 more between now and the end of the year. We've had less service issues, more stability, and fewer hardware failures with this platform so far than any other platform that we've launched into existence at Rackspace. So you can be very successful even with a mature offering like Rackspace's cloud servers platform, bringing open compute into an application that already exists. This is another one of my customers. Rackspace goes through periodic purchases of smaller companies. This is Ev Consovoy. He came to us through a purchase of a company called Mailgun. And shortly after we acquired Mailgun, Ev was in a media room where we produce some of our videos that we put out on YouTube and so forth, interviewing on new and exciting things that he was thinking about for developers and so forth. And you can see the whiteboard in the back of the room. I snapped a video frame of his interview here. Of course it's impossible, of course it's insane, but we're going to do it anyway. This is one of my customers. This is the other end of that gamut. And Ev was saying at the time that he had an idea. He coming in, had used public cloud infrastructure before, and he'd used colo infrastructure and dedicated infrastructure. And he said, you know, all of these cloud environments, they're good. They suit us pretty well, but I want to build a new cloud. I want to build a cloud that has teeth, more teeth. And we called it Project Teeth for a while. And here was his sort of foundational idea. He said, these multi-tenant cloud environments that we use, their behavior and their performance and their availability is less consistent than I want. Sometimes all of these gauges are in the green. Other times they're in the red. You heard Billy talking about this, that people sometimes like to cherry pick on public clouds. You know, maybe I'll spin up 10 more instances than I need to find the one that is highest performing and most stable. You know, what an end user really wants is for every one of them to perform at about the same level of consistency, but sometimes that's hard in shared hypervisor environments. So Ev said, look, those environments are good when you're prototyping, and then we start growing. And growth is the hardest part. We're breaking into all of the areas where we have bugs, where we have scaling issues, and this is at a time when our customers are coming on and they're the most demanding and the most issues are sort of on the table and at stake for whether or not we're going to be viable as a company and our brand is going to be good. And we get past that and we get to a point where we can just start optimizing our infrastructure and making it cost effective, then we're comfortable again. But this inconsistency in these clouds and these applications sometimes causes us problems. So, you know, when we don't have a lot of money and when we're in startup mode, we want to prototype on these multi-tenant clouds. But when we hit that real spike in our growth, we don't want to stay there because of this inconsistency. And so we end up going to colo. He was saying, I was a customer of Rackspace and other providers. And my best option was to take it to colo as quickly as I could once I thought it was viable. So this is the side of the spectrum that we need to solve for. And we said, okay. So it really comes down to 2 trade-offs as Ev saw it. If these are the 2 choices, one's very simple to scale and elastic, and the other is not. So how do we solve that? That's this cloud with teeth. So this gets to our story of integrating OpenStack and Open Compute with Ironic that we used to turn out a new service this year, just a few months ago, that we call Rackspace's Onmetal Cloud Server Service. This is a dedicated single-tenant platform that provisions and deprovisions at cloud speeds. And since it's dedicated, its performance level is very consistent. It's designed to be the highest performing platform that we have at Rackspace. This brought in both new hardware that we had not deployed before and new components in OpenStack that had not been used in wide-scale production before. So we had developers on both ends with all of the risk and ambiguity that could come with that, working on this platform at the same time. And we had about 2 months from initial concept until we were asked to put out our first field trial with the platform, which is pretty aggressive. Now, what we noticed in this as well is Onmetal required that we deliver some new features in the platform. In a big multi-tenant environment, shared networks and so forth, and a cloud, a hypervisor brings you a lot of things that you need in order to keep your customers secure, separated from each other, and to keep your provisioning system moving very quickly. And if you take that hypervisor away, you have to find some way to replace some of those core functions. So we also ended up needing to go deep down into the firmware of the platforms that we were using and changing how they behave so we could give the end users all the power and performance that they wanted without risking the separation and security domains that we bring to our customer. We did all of this in just a few months' time. It took us about 3 months from the point in time when we realized what we needed to do in the firmware of the platform to be tied to code in Ironic and to be tied to the servers that we were deploying, to the point where we had a really stable beta platform going. And in our traditional model of deployment, through our traditional engineers and solution providers, we are still working on getting the firmware features that we need into that platform today. We continue to work with them, but the speed at which this little team in this community could move is much, much faster than our traditional venues, our traditional ways of doing business. So we've deployed north of 3,000 servers at this point in time using this model, and that will continue to ramp because we've only touched one, that little yellow square, one core set of applications at Rackspace. But it's been so good that we intend to expand this to the point where we are covering all those applications. And in order to do that effectively, I think we've transitioned from saying that we need to use a traditional model that's sort of known and low risk to a model where we have all the control. The better model is the one where you as an end user, you as an IT shop, have this level of control over your infrastructure. And I think our story is the amount of incremental investment you need to get there is relatively small, and it pays off in spades. I want to talk for just a minute about what we've learned in that process, things that we've learned. We talked a little bit about this last year. One of the first things that we've learned is we do best when we get equipment out in the hands of our users as quickly as possible. So if you are going to get involved with Open Compute as an IT shop function, go out and get some and put it in. Get those users working on it. We've learned that developers like it when they can touch stuff, they can put their hands on it, either physically or across a network. And if you are looking at these systems and saying, what can I do with it? Don't spend a lot of time just writing stuff on paper. Go out and get some platforms and put them in. That's one of the things that we've learned. Another thing that we've learned is that we can take open much further than it is today in the world of hardware and get additional value, and I want to talk about that just a little bit later. We did make some investments along the way, and the community has done the same. I think if you look at Open Compute as it exists today and all of the different domains that it covers, you might get the idea that there was a very deliberate philosophy put forward to determine what we were going to bring into Open Compute, how soon we were going to bring it online, and what it was going to look like as a product or a deliverable. You can look back and see it that way, but when you're working on it day to day, sometimes you feel like we're on a train moving down the track and just barely laying out rail and ties and so forth just ahead of where we're going. The investments that we make They take some time to pay off, just like the team that we built at Rackspace initially, but the momentum that we develop along the way and the speed at which we're going is definitely worth it. So those investments, those incremental investments are critical. It's not completely free getting into it, but it does pay off. Gains that we've made. As a company, we've had those benefits of performance and those benefits of energy efficiencies and cost savings and so forth. And as a community, I think we've seen customers and other players do the same. But I think the biggest gain, the area where we've harvested the most, has been in the actual facilitation of bringing all of these different parties together. Software developers, hardware developers, firmware developers. As you saw in Cole's slides at the beginning, when you take out what separates those parties and you put them together and you start them working on new and interesting ideas, you really can get a great deal of movement in areas that you might have otherwise thought were kind of not going to move, things that were slow or locked down in our industry, things that don't change. And you hear Billy use words like disruptive. You hear Cole talk about wanting to connect the end users more closely with the producers of the technology. These are the kinds of gains I'm talking about. We don't need to pretend that there need to be separation between those groups. Those groups actually do really well at this point when we put them together and get them working. So if we put gear in the hands of the end user, we recognize that we need to make some small investments along the way. And then we think about all of those gains and how quickly we get them. I think there's a compelling case for bringing this to our customers. With a relatively low level of effort, you'll get started. And in time, you'll be building that train. And we're getting to the point at this point where we have customers outside of the company coming to us and saying, we want open compute platforms, we want openstack services on top of them, and we want Rackspace to do it, which has created some new business models for us. And I think you see the same with Kushagra's presentation as well. How about a common infrastructure with a common set of core applications and then a wide opportunity to innovate across those? Now, when we say common, we don't mean tightly restricted where there's nothing you can do. We mean common where we've brought everybody together and we've had all of those groups identify what the best core solution is and then evolve it together over time. So what's next? We've got a bunch of words flying around right now in the business. We've got words like disaggregation and convergence, and we've got some opportunities to push what we call open today further. And that really hinges on whether or not we get more engineers and more developers into the mix. Let's start by talking about disaggregation and convergence. Like this DNA helix that you see on screen, today the way that we do computing is sort of built into how we think. The way that we do servers is sort of built into how we think. We've been doing it a certain way, kind of the same way, with the exception of movements in the open source communities for a long time, and we've been doing it because it works, and there's not a lot of unknown. So it's easier to plan, it's easier to de-risk. I think the challenge we run into right now is fundamentally these technologies, as we've traditionally used them, are not scaling, they're not delivering the gains that we want anymore. We need to change our DNA. So we hear words like disaggregation. Let's take things that are in the system out of the system and put them somewhere else. Let's scale them separately. Let's scale disk and memory and compute differently than we have with traditional motherboards. And then we hear other words from people that are designing silicon and memory systems and chips saying, in order for us to continue to improve our performance, we're going to put together a lot of these core functions. We're going to integrate them more tightly on the chip. So you have disaggregation and convergence happening at the same time. And then we've got this status quo that we're working with. And that needs to change. If we have communities like OpenStack and Open Compute working in tandem with many of the other companies, AMD, ARM, Intel, people working on ARM designs like Cavium, IBM, and OpenPower, if we as developers and engineers get close to those groups as they figure out how to solve some of our next problems, we won't end up with proprietary functions that are difficult for us as developers and engineers to work with. Now, we're seeing them open up and saying, come closer to us. we can customize for you more. We can give you more of what you want. And that could be core counts and clock speeds, or it could be things that are much more sophisticated, like instruction sets and memory systems and accelerators and so forth. I say, let's get developers closer together with them today. Let's think about open as a work in progress, where we have solved for quite some time the questions of rack and electrical and chassis in these systems. And we've started to solve questions of disk and network, and we've definitely solved software. But there are many more pieces to the puzzle that we want to lay in. If we want more open memory systems, firmwares, processors, sockets, board interfaces, management systems, if we want that, we need to get those developers closer. We need to make open go further in our space than we do today. I like to call that open all the way down. Okay? Sitting underneath this environment that we have today in areas that are still closed, we have this delightful creature, this very new and creative opportunity to unlock new value for our business. We saw it at Rackspace with Onmetal. The further down we go in the stack, the more open we go, the more opportunities that we have. I'd mentioned earlier that Rackspace had done development work in our Onmetal service, and we had to touch the firmware. And we got close to those systems by virtue of the fact that we were doing development in Onmetal, but firmware is still a spot that was closed for us. So we did a lot of work that could add value to other end users, but unfortunately that's something that's difficult to share. And if we get open further down that stack and we start touching into some of those other components, today, where we're growing, we're making progress, but we keep pushing into that space, we can continue to unlock some of these other parts of the stack and continue to get more value. And that makes not just for value for end users and businesses, but as developers and engineers who have a passion for this, this gives people an opportunity to spread into new domains and new areas, revitalizes careers, revitalizes some of the academic interests that go with this, the university studies and programs and so forth. I say we open it up and we get all of these people working together, and we'll end up with good things. Now that perhaps seems a little optimistic, a little Pollyanna. This is a picture of developers when you just meet them at a conference or a room from a previous open community event. But I have found in my experience sometimes that when you take those developers and those engineers and you empower them with open source, you go from something that looks like this to something that looks like this. Sometimes developers on open source get so empowered and they want things to change so fast that things get a little disrupted, they get a little angry, they get a little difficult, especially for core parts of systems that maybe can only change at a certain pace or only after certain fundamentals are understood. So as you as developers here and across the community get closer to these core components in our systems in OpenStack and Open Compute and other environments, I want to encourage you to realize that the opportunity that we have here is significant. The opportunity that you have to engage is unprecedented. But the opportunity is given by people that are opening up parts of their technology where they still need some fundamental elements of it to stay the same for it to be stable, for it to function right. So we invite developers into that space. What we want to do is engender a really healthy dialogue, a really healthy development mentality between the two groups, and not have our open source developers be an angry mob that just wants to run over everything and reinvent the world. Sometimes there's not much left over when we go in with that mentality. But when we go in more as partners, we do really well together. Finally, I want to talk a little bit about why OpenStack and Open Compute matter to each other. Today, when I hear people talk about OpenStack and Open Compute, they say something like, man, wouldn't it be cool if I got some OpenStack equipment and I got some Open Compute equipment and I put OpenStack on top of it? That would just be really cool. And you can do that. Today there are a number of OpenStack distributions and there's a variety of Open Compute hardware that you can acquire. But I kind of think about that like not much different than if you just got a server and installed an operating system on it. I mean, it's neat, it's doable, but the value comes afterwards, and the value comes from getting deeper into the system. Today we have a lot of OpenStack developers that think mostly about abstract services. They think in abstract languages, and I think for good reasons, many of them don't think much about the hardware that they're putting their application on. In fact, sometimes it makes sense for them not to. But there's a new breed of OpenStack developer that I think we need to work together to create. And that OpenStack developer knows more about the lower level parts of the system. They understand servers fairly well. They understand some of these lower level interfaces and firmwares. We can wrap things like IPMI and a REST interface, but I don't know that we want to wrap things like SCSI or PCI Express protocols in a similar function. We need to let them be what they are. We need to get developers closer to them so that as they evolve, we can get more value out of those two systems. So I want to encourage those of you that are here that are going to be attending the OpenStack Summit next week. Start talking with people that are working on some of these core functions about what are we going to do when there is disaggregated memory? What impact is that going to have on the system? What are we going to do when FPGAs and GPUs start showing up heavy in OpenStack environments and people say we want to do something with them? And what are we going to do as some of these silicon providers say, hey, we're opening up our systems, our design, our chips, our architectures. Come on in. We need you here. Now, are we going to respond by saying, well, I can't develop that in Python, so I'm not going to do anything with it? I say no. I say, let's get them closer today. Let's get them talking now so as these technologies start further into the development process and they start to hit the market, they land ready for the developers and the engineers that we have today. Thanks, everybody, for your time today. I really appreciate it sitting through the past couple hours of keynote session. I hope this has been very useful and constructive for you. I really appreciate the opportunity to share this information with you, and I hope you have a good time at the rest of the summit.
Thank you. Aaron. Guys, just another quick round of applause for this amazing slide. I love this. So Aaron, make a grandiose prediction about the next 5 years for Open Compute and OpenStack. What do you think happens? This is your crystal ball.
Yeah, this is what I hope for more than what I think the prediction is.
Okay.
I think that for things we get excited about today as developers, GPUs, other accelerated compute functions, that we're going to see an opportunity to start building clouds that recognize these components like they're special functions. It's not just memory and disk and compute anymore. Now it's all kinds of specialized memory and disk and compute that operate or offer extra value to us. Amazing. And I think OpenStack can give that to us.
That's awesome. Aaron, thanks everybody again. Thank you, Aaron.
Thank you.
So I think I agree with Aaron. I think I see, again, gratuitous differentiation being ripped out of environments. Now, what we see here early on when we create these type of projects, we never want to be the bottleneck in terms of what gets created. So there's no, unlike the Linux ecosystem, which sort of has this benevolent dictator type model, the OpenStack and Open Compute ecosystems are very community friendly, and it's kind of a choose your own adventure story. In that model, when these initiatives initially kick off, you can get to a very wide net, but that net slowly gets a little smaller. And I think and the beauty of this is the community ultimately drives how wide or how narrow that net becomes. And I think we're seeing some really fantastic contributions to both of these projects right now on solidifying on common interfaces, common standards, et cetera.